Yeah, it does, and yeah, and it was long. So section C was all about the arithmetic sequences when you were adding to get to the next term. So we're going to talk about geometric sequences. And if you had to guess, what do you think you have to do to get to the next term in geometric? Multiply, absolutely. So I am going to split up D1, and then there's actually a D2 and a D3 that we'll do together on Monday, and we will have some separate notes because there's like a different formula that's not in your packet. That'll be Monday though. Did you use that box? All right. So geometric sequences is when each term can be obtained by multiplying the same constant to the previous term. So just like you guys thought, you keep multiplying the same thing. Now, those sequences also look like dividing, and that's when we would multiply by a fraction each time to keep going. And I'll explain why on the next slide, but that constant that you multiply each time is called the common ratio. So that's the big difference, is that in the arithmetic sequence, it was the common difference. Well, when we work with geometric sequences, that thing that we keep multiplying is called the common ratio. Now, I'm going to explain how to get the common ratio on the next slide. And there is a formula. The formula is not in your packet, but kind of like common difference, I don't think you'll really have trouble remembering how to find the common ratio. So the formula is you take u sub n plus 1 divided by u sub n, but again, let's try to not have to remember a formula. All you have to do is take a term and divide it by the previous term. So just like we were subtracting, it's pretty much the same, but instead now you're dividing. So you're taking a term and dividing it by the previous term. So just a little background information about why we call it the geometric sequence. And I don't know if you guys remember this from geometry, but there is a geometric mean. So if A, B, and C are any consecutive terms of a geometric sequence, so we got a list, we got A, B, and C, we can actually equate those common ratios just like we did with the arithmetic sequence, where B divided by A is a common ratio, and C divided by B is a common ratio, so we can set them equal to each other. Now, the geometric mean then, if we kind of go to cross multiply, we end up with B squared equals AC. So if we get B by itself, it's the square root of AC. So I don't know if you remember it, but there was that number that could fit in this proportion is the geometric mean. I know if you took CP geometry that you guys talked about this, but I also know that was a long time ago. We won't use it so much, except for we'll have one problem where we'll use equating the common ratio. And someone in my second hour kind of noticed that she thought it was a lot easier to maybe just use this formula here to kind of figure it out, but then you'd have to memorize that. So we'll see. We can talk about that when we get to it. And then here is your super important formula that is in your packet. And you'll notice that a lot of the stuff is very similar or the same as the arithmetic sequences. So n still stands for your term number. U sub 1 still stands for your first term. The difference here is that it's not like adding and subtracting. We actually take the first term, multiply it to the common ratio, raise to the power, and the power is that n minus 1. So we have a lot of the same pieces. Okay. So like we already mentioned, R is standing for the common ratio. The use of n is still a term, just like it's been a term all week. All that stuff is the same. And you do have to follow those order of operations again, where you have to figure out what's in your parentheses first. Then you have to do your exponents, and then you can multiply. So always, always, always follow those order of operations. I do recommend locating in your packet. They don't go like in order that we do them in class. They're listed differently in the packet, so make sure you can see where it says general term for geometric sequences, so you know where to look for that. All right, so kind of like Wednesday, we're going to have 3 examples with the same sequence. So this is the sequence we are going to take a look at: 12, 18, 27, 40.5. Okay, so we need to find the common ratio. So find the common ratio. Show that that's geometric. So take a number, divide it by the previous number. So 18 divided by 12. What do you guys get? 1 and 1/2, 1.5. And again, since it's a show that problem, we do have to keep doing this to show that it is geometric, but a lot of times you can just do it once and call it in and have your common ratio. But if I do 27 divided by 18, sure enough, we get 1.5. If I do 40.5 divided by 18, we get 1.5. So my common ratio is 1.5. And you'll often see me use the fraction instead of like a decimal. I mean, I think you guys know that about me. The more often than not, I go with the fraction. Does anyone know what 1.5 is as a fraction? That's a mixed number. As a fraction, it's 3/2. But yeah, you were right. 1 and 1/2. That's just a mixed number. Okay, any questions about like finding that common ratio, showing that it's geometric? Just for fun, what is the first term? 12. For some reason, last hour I had like 18 stuck in my head. Nope, the first term is 12. So now we're going to use the same sequence, and we're going to find use of n. So remember, use of n is the general term. So if you find a question that says find the general term, means the same thing. So we'll use the formula. And remember, the general term, we will keep n in our formula. So then we can just put the first term in the common ratio. Sometimes I like to use parentheses too to show that I'm multiplying, just so I don't get confused with like the decimal points and stuff, but either way. Can we simplify this anymore? We actually can't, because like that's not a distribution, it's to the power of n minus 1. So we're done right here. There's nothing else that we can do on this one. Are you guys still feeling okay? Let me know if you do have questions. So, one last problem with this same sequence, and that is to find the 53rd term. So, kind of like we talked about before, you've got 2 options. You can use your original formula that I have up here in black and plug everything in. Or if you've already written the general term, you can go ahead and plug it in there. So keep in mind 53rd term, that means that 53 goes in the n spot. So use of 53 equals 12 times 3/2 to the 12 minus 1, not 12, 53 minus 1 power. Now, a lot of you guys will skip that step and just write 52, and that's completely fine. In fact, a little bit later today on an example, I'm going to ask you if it's okay if I skip that step, but just wanted to show you guys that for now. So if I end up with 12 times 3 halves times to the power of 52. Now, if you do just shove that on your calculator, just be careful. I like to do the power part first. So when I do the power part, if you do it separately, please be careful and don't do like too much rounding to start. So I'm going to write down this whole thing here because I don't want to round too much. Like I know it's 3 sig figs, but don't do that till the end. So if that could be too many numbers for you to write down, that's fine. But then just be careful with your calculator usage, that's all. Keep in mind the less work you have, the harder it is for me to figure out what happened if you get it wrong. But now you guys know that like this will stay in your calculator, so you can just click it and do times 12, right? What happens when you go all the way? What does your calculator say? Okay, puts it in scientific notation. Does anyone have like E? Do you know what that means if it does? Okay, so like mine says 1.721578051 E10. The E10 means in scientific notation times 10 to the 10th power. So if it was like the 6th power, it would say E6. Does that make sense? So just to know how to read your calculator. And here is the point where we can do the sig fig, so 1.72 times 10 to the 10th. So again, mine had E10, well that just means 10 to the 10th. This 10 goes with that. We are going to hit the stat box and then do the 2 funky type problems. Are you ready? Are we okay? So that common ratio is so important. I do want you guys to just take a second in your stat box and write how it is you find it, whatever makes sense to you, because you won't have that formula in front of you. Anyone want to share what they said? I'm hoping you wrote something like a number divided by the previous number. Something like that. Okay, so again, this is that funky example with the k's, where we've got all these k's. We've got k, k plus 8, 9k, and we need to figure out what k is. So we can use equating the common ratios here. Now, what was brought up second hour is that we did have a little formula that was the geometric mean formula, which was, I'm just going to write it in the corner, b equals the square root of a times c. Now, if you want to memorize that and like go for it, I'm not going to stop you, but I'm going to do it another way that we hopefully won't forget, which is, I know the common difference is a number or a member minus the previous member of that term, or not minus, divided by, so I end up with k plus 8 divided by k equals, okay, number divided by the previous number, 9k divided by k plus 8. Now, believe it or not, you have seen something like this before. Any ideas on how to proceed? Absolutely, we can cross multiply. So k plus 8 and times k plus 8. So multiplying those, it equals k times 9k. So then I end up with k squared plus 16k plus 64 when I FOIL the left side. I've got 9k squared on the right side. I know that some of this stuff I'm going through a little bit fast, but we have done that, like I said before, in chapter 1. Now that you guys are seeing the k squared, it should look even more familiar. Those quadratic bells should be going off in your head, which means I either have to factor or use quadratic formula or complete the square if I'm really feeling that vibe. You know, I really like to keep my k squared term positive, so I'm going to bring everything over. So I'm going to end up minusing the k squared. And then minusing these as well. What was that, minus 16k? So we end up with 0 equals 8k squared minus 16k minus 64. And you'll have to decide how much work you want to show for that. Now that we get that far, you guys can decide, what do you want to do to solve it? You like factoring? I like factoring too. I'm going to factor this, but you guys hear me when I say that if you are a quadratic formula person, do quadratic formula. That is in your packet too, so you can always flip back to that, put a star by it or something. I saw Austin say we can take out an 8. So I've got k squared minus 2k minus 8, which is great because now what's in the parentheses is that quick factoring. So the 8 stays on the outside, but what are my factors of negative 8 that combine to equal negative 2? Very good. So I'm just going to bring the rest of it up here. 0 equals 8 doesn't really do anything, but I have 0 equals k minus 4 and 0 equals k plus 2. So k equals 4 or k equals negative 2. Those are both potential answers for k. There are 2 different options. I know that's a lot, and again, I think there's only one problem like this on your assignment, but I feel like it's a good review of some of those strategies that we use to solve quadratics and that sort of thing. So it's kind of nice to have that stuff cycle back so we don't forget it. We have one last funky one, and I think we're doing all right on time. Any questions? Okay, so example 3 is find the general term of the geometric sequences. It should be just sequence. When the 7th term is 24 and the 15th term is 384. So the general term is given by this formula. So I need to figure out what's my common ratio and what's my first term. Unfortunately, we don't have 2 terms that are next to each other. We have the 7th term and the 15th term. I cannot just subtract. If it was like 7th and 8th, I could just subtract, but I can't. But I can write some formulas. Now, I'm going to probably go through this a little bit fast just so there's a little bit of time for questions at the end. But kind of just stick with me. There's a couple opportunities for you to practice this on your assignment. And again, it's one of those where it's using some other skills. But what does this mean when the 7th term is 24? The u of 7 equals 24. So that means that if I put 24 in here, I don't know the first term, I don't know the common ratio, but then that would be 7 minus 1. So when n is 7, my whole thing equals 24. Because it's that 7th term. So when n is 7, it equals 24. So I'm just going to go ahead and write that as that 7 minus 1 is 6. And I can kind of do the same thing with the 15th term. term, so the 15th term is 384. So 384 equals the first term times the common ratio, and then that's when n is 15, so that's 15 minus 1. So 384 equals the first term times r to the 14th power. Now we need to figure out what the first term is and what the common ratio is. These are sort of weird, right? Now it's going to be hard right now to get the r by itself and get the r to cancel out because I have r to the 6th and r to the 14th, but this u sub 1 is sort of by itself. I can actually get it by itself if I divide by the r. So if I divide by the r, my first term equals 24 divided by the common ratio to the 6th power. Again, just kind of stick with me here. And we can do that same thing. So I can take my first term equals 384. It's not showing up so good on the red. 384 divided by r to the 14th power. Now that they're both equal to u sub 1, any thoughts on how we could kind of keep going here? Yes, well, I'm going to do something other than cross multiply. That's a really good thought, but I'm going to kind of take it as a different way. But absolutely, now that they both equal u sub 1, I can set them equal to each other. So I have 24 over r to the 6th power equals 384 over r to the 14th power. And actually, you could definitely get where I'm going by cross multiplying. You might just take an extra step, but you could. Now, we already talked about geometric mean and bringing you back to geometry. Sticking with bringing you back to geometry, one thing I know you guys talked about is different properties of proportions. You could flip them both over, but you can also write them a different way. So I could actually take this same proportion and write it as 384 over 24. So those still go together, and then I can write r to the 14th power over r to the 6th power. When I teach them in geometry, I tell them to tilt their head to the side and kind of look at it like that a little bit. Because this is going to simplify a lot better for us. Because I can take 384 and divide it by 24. And I end up with 16. Okay. And we've talked about in here, if I've got r to the 14th over r to the 6th, what can I do with those powers? So it's r to the 8th power. Now we're getting somewhere. We can get r by itself here. Now, there are a few different ways to do it. What do you guys think? If you had that on the ACT or something weird, or when you were in a crunch and you had to figure out what it was, what would you do to get r by itself? No ideas? Okay. So one thing I was thinking of is I'm much more comfortable with an r squared, right? So this is not how we did it last hour, because they came up with an idea. But if I divided this power by 4 or times by 1/4, or take to the power of 1/4, then that would equal squared, which I'm a little bit more comfortable with. Do you guys remember how 1/4, the power of 1/4 is the same as the 4th root? So that's going to bring this down to, let's see, r squared. What's the 4th root of 16? Or what times itself 4 times equals 16? 2. This is getting pretty cute, because now I can square root, and r equals the square root of 2. Now, I get that that's kind of weird, and you might not see that right away, and you're okay, and there are other ways to get there, but just kind of push yourself to keep remembering these things. Okay. So now that I've got the common ratio, how do I figure out my first term? Yeah, you can plug it in. You can plug it in wherever you want. I'm actually going to plug it into this one. So then my first term is equal to 24 divided by the square root of 2 to the 6th power. What's the square root of 2 to the 6th power? do you guys get? It is 8. So I end up with 24 divided by 8, which is 3. Now that I have these things, I end up with my first term is 3 times the square root of 2 to the n minus 1 power. So again, I know that's a lot. You're not going to see it a ton, but it's really kind of refreshing some of those skills that we don't use all the time. I know sometimes in math you get stuck in like, well, I'm in this chapter, so I only need to remember what's in this chapter, but we've got to bring those skills back. And definitely feel free to ask questions on Monday. These are like, I think the last 2 problems are like this, so definitely check out the notes, but ask questions if you need help. So I think almost exactly the same amount of time as 6 hours. We've got second hour. 7 minutes left for questions.